All right, daily work 3-2. When solving, assume that the preceding problems are no longer true. In other words, don't assume that something you got in question 1 is going to be true for question 2. So after question 1, we have to go to the picture and start all over, okay? So don't forget that. In this particular picture, a lot of times in geometry pictures, we'll finish the whole picture and then answer all the questions. In this one, we're going to take one question to the picture at a time and forget what the last question said because it's probably not true anymore. Okay, angle 1 is 70 degrees. Given that angle 1 is 70, find angle 9. Well, angle 9's right here. Angle 1's right here. When you put angle 1 with angle 9, they make the letter F, which makes us think of corresponding angles. Now, we know that corresponding angles are equal if the two lines are parallel. So we have to look at the two lines that form that F and see if they're marked parallel. Well, that one was, and here's the other one. So it is marked that the two lines that form angle 1 and angle 9 are parallel. Angle 1 and angle 9 are corresponding angles. If two lines are parallel, then corresponding angles are equal. So we reach the conclusion that angle 9 is 70 degrees with the reason corresponding angles are equal. Now, we're not going to put F's are equal. We're going to put corresponding angles are equal. We're going to use proper terminology. The F is for visual aid purposes only. Okay? Okay? Let's look at number 3. Angle 9 is 50 degrees. So we're going to draw angle 9 because we're looking for that association with what letter it forms. And then angle 14. Well, angle 14 is right here. And you say, well, that makes an X. We didn't talk about X's. Well, we did talk about something that looks like this, though. What are those called? Well, you might remember that from the past, angles opposite each other when two lines intersect. Opposite angles each other when two lines intersect are called vertical angles. And we know that vertical angles are equal. Vertical angles are equal. That has nothing to do with parallel lines. That has to do with intersecting lines. When two lines intersect, then vertical angles are equal. Vertical angles are angles opposite each other when two lines intersect. That's our definition. The formal definition is a pair of angles formed by two pairs of opposite rays, which is a little bit difficult to figure out what that's trying to tell you. Okay, now let's look at number 5. Angle 16, and we want angle 20. 16 and 20, so let's look at those two angles. So if we draw angle 16, we'll start with its vertex and its two rays, and we'll stop when we get to another corner. And then we're going to say angle 20, and we're going to draw it. And when we draw angle 16 with angle 20, you see that it makes the letter C, so they're same side interior. Now we know that same side interior angles are supplementary if the lines that form them are parallel, and we do have one arrow showing that those are parallel. Now I'm not sure in your student edition, this should have been a double arrow either here or on the other side. So we should have double arrows to show different parallelism. Anyway, hopefully that was fixed in your student edition. If not, you might make that adjustment in your student edition there. So same sides make a C, and they're supplementary. So we can take 180 degrees minus angle 16, which was 56.4 degrees. And that'll give us angle 20. So that's going to become a 7 and a 10. A 10 cancels out to a 9, and that's still a 1, sorry. And that's a 10 minus 4 is 6, and 9 minus 6 is 3, and 7 minus 5 is 2, and then there's a 1. And so angle 20 would be 123.6 degrees. Reason, same side interior angles are supplementary. Same side interior angles are supplementary. Any questions on that? Okay. Let's just go ahead and do question number 8. It's got some good fractions in it. It says angle 4 and angle 7. Now we got to go find angle 4 and 7 first. Angle 4 and 7 are angles opposite each other when two lines intersect. Those are vertical angles, so we know that angle 4 is equal to angle 7 because vertical angles are equal. So we'll go back to our problem, problem number 8. I'm going to white out some stuff down here below so I have plenty of room to work. And so we know that since angle 4 is equal to angle 7, then we can say that the measure of angle 4, which is 4 and 1/2 x minus 1/3, is equal to the measure of angle 7, which is 2x plus 75 and 5/6. Now, we're making you have to deal with fractions here because people are scared of them, and we need to not be scared of them. What we're going to do is eliminate the fractions. And we're like, okay, we're going to make you deal with them, so the first thing we're going to do is get rid of them. But that's something we need to know for Algebra 2. To do that, we're going to make these improper. 4 times 2 is 8 plus 1 is 9 over 2x minus 1 over 3 is equal to 2x plus 75 times 6 is 420 and 30 is 450 plus 5 is 455 sixths. Let me check that. 420, 30, 455. Good. 6. Now, what we learned in algebra is that if we didn't like there being a lot of fractions, then what we would do is find a common denominator between all of the denominators and multiply through by that, and that would make there not be any fractions. Well, the common denominator between 2, 3, and 6 is 6. So we're going to multiply each term on both sides by that denominator 6. Now on this one, 2 goes into 6 3 times, so we have 9 times 3 is 27x. On this one, 3 goes into 6 2 times, and so we have 1 times 2 is 2, but it's a minus 2. On this one, we have 2 times 6 is 12x. On this one, the 6 cancels the 6, and so we have plus 455. So by multiplying through by the common denominator, we have eliminated the denominators, and now there's no fractions to deal with. If we refer to the order of operations horseshoe on page 33 of my student edition, it says to do anything you can in the order, please excuse my adherence, Sally, to simplify. But there's nothing that you can do to simplify either side. We would have drawn the little arrows and talked about simplifying in Algebra 1. And then the bottom of the horseshoe is something that in Algebra 1 people struggle with. On the bottom of the horseshoe on page 33 of my Algebra 1 text, it says this: get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. That is a step that we do between doing and undoing. I call getting the stuff off of a variable, isolating the x, I call that undoing, see? Okay? And so then we're going to have 27x minus 12x is 15x minus 2, and those cancel on that side is equal to 455. We've done all we can do to simplify. There's no longer a variable on both sides, so now it is time to undo. We have multiplication and subtraction. We undo in the reverse order of operations. So we undo subtraction first by its inverse addition. So we add 2 to both sides. So we'll have 15x is equal to 457. Now we're going to undo multiplication by division. We're going to have 457 divided by 15. Now, in Algebra 2 and college algebra and upper level mathematics courses, we generally let you write the answer as an improper fraction. So this would have been an acceptable answer. But since the problem was written with mixed numerals in it, and there's times in real life you need to know how to find a mixed numeral on paper, we're going to go ahead and change it back into a mixed numeral. To do that, we're going to do what it says. It says to divide. 457 divide 15. Well, 15 will go into 45 3 times. You get 45 with 0 left over, and you would bring down a 7. And then we would say, how many times will 15 go into 7? And it will not go. And so we put a 0 as a placeholder. Well, if you want a mixed numeral, once you get to that last position, once you get to where the decimal is, then instead of adding a 0, you put your remainder, which is 7 in this case, over your divisor, which is 15 in this case. And so we would have 30 and 7/15. 30 and 7/15. And our reason for saying this was vertical angles are equal. Okay? Any questions on that? So that's a good exercise in Algebra 1 solving equations. And you can do the other two on your own. That'll be good practice for you. We have some more proofs here, and I was just scanning there just a little bit to see what we've got. Let's start it on this proof, and then we'll let you finish it on your own. Remember to actually write a proof. You write the given proof, put the statements on the left, reasons on the right, draw the diagram. That's all been done. In this particular proof, it already has statements, and we're just giving reasons. Remember, when you give reasons, where do you look first? You look first at the given. You look second at the diagram. And you look third at the statements above. But before you go to looking for reasons, we're going to take what we're given, mark it on the diagram, write statements and reasons derived from the markings of the note section. So we're going to make us a little note section. It says angle 1 is equal to 60 degrees. And so we'll just write that down, angle 1 equals 60 degrees, and that's the only conclusion we reach there, and so we're going to put given. Now, if it said given something's a midpoint, we'd think, well, what do we get out of that? Well, two equal segments, so we would mark that in the diagram and write that in the note section. Or if it said given something's an angle bisector, then in the picture we would mark two angles are equal, and then we would say in the notes that those are equal reason, definition of an angle bisector, C. Okay, so we're going to start giving reasons. I'm going to go ahead and put that 60 degrees right there. And so statement 1, angle 1 plus angle 2 is equal to 180. And some people think you put given first every time, but that's not in the given. See, we're going to look first in the given. Does it say first in the given? Does it say in the given that angle 1 plus angle 2 is equal to 180? No, it doesn't. So if it's not in the given, then we're going to look second in the diagram. Can we see in the diagram that angle 1 plus angle 2 is equal to 180 degrees? Well, we can. What did we see in the picture? Well, we saw that a straight angle is 180 degrees, and what we call that is the definition either of a straight angle or the definition of a linear pair. Now, since we're actually dealing with the angles, then definition of a linear pair is probably a better answer. This is why you go to the diagram, because there's some things you just flat see in the diagram, right? Okay, so the first one wasn't given in this particular proof. We go to the next reason, angle 2 is equal to angle 3. Angle 2 is equal to angle 3. So we look in the given. Does it say that in the given? Nope. So it's not given. So we go to the diagram. In the diagram, can we see that angle 2 is equal to angle 3? Well, they make the letter F. Do we know the lines are parallel? We have to know that first. Yes, that arrow shows they're parallel. So from the picture, we can conclude that angle 2 is equal to angle 3, and we should mark that because corresponding angles are equal. Now, we had to know they were parallel first, but that was marked in the picture for us. The next statement, angle 3 is equal to angle 4. Angle 3 is equal to angle 4. So we go to the given. Does it say in the given that angle 3 is equal to angle 4? Nope. So we go to the diagram. Can we see in the diagram that angle 3 is equal to angle 4? Angle 3, angle 4. We see an X. Those are angles opposite each other when two lines intersect. That's called vertical angles. And we know that vertical angles are equal. So we know that angle 2 is equal to angle 3, and angle 3 is equal to angle 4. And we go to the next statement. The next statement says angle 4 is equal to angle 5. So we go to the given, and it's not in the given. And so we go to the diagram. Can we see in the diagram that angle 4 is equal to angle 5? And so we're going to draw angle 4 and angle 5 and see what we have. And when we draw angle 4 with angle 5, we see the letter Z. So we realize that they're alternate interior angles. But we can only say that alternate interior angles are equal if the lines that form them are parallel. And here we have a double arrow and a double arrow. And that shows us that those are parallel. And so we can reach the conclusion. Okay. And I'm going to stop there because I've already done a whole lot of the proof, and I'll get carried away and forget to do the whole thing because I'm just having fun. Anyway, so you can kind of keep going from there. All right. Don't forget about all those properties. that we learned. Properties like substitution, transitive property. These are things you learned in geometry and in Algebra 1. Substitution, transitive property, addition, property of equality, subtraction, property of equality, multiplication, property of equality, division, property of equality, symmetric property, associative property, commutative property. So we have a whole list of properties that could possibly pop into that, plus every definition, postulate, and theorem that we've learned this year in geometry. So you can see that to be able to do proofs, you have to have a process that you understand, but you also have to know verbatim every definition, postulate, and theorem that you've ever learned in mathematics. Okay. All right. Number 11, we're going to go ahead and show you again how to do a two-column proof, and we hope that you will be able to do these on your own. There's going to be some on tests, so if I do the two-column proof and you watch the video, don't just copy it down. Put it aside and try to do it on your own, and then try to do it again later when you've had time to just forget exactly what we did and see if you can think your way back through it again. That's all a part of learning, okay? So, to do a proof, we're going to write the given proof, proof. Put the statements on the left, reasons on the right, and draw the diagram. That's just getting the chart set up. Write the given proof, proof, put the statements on the left, reasons on the right, draw the diagram. Let me remind you again that the proof is this set of statements and reasons. People say, what do you put by proof? The proof is the statements and reasons. You don't put anything beside proof. Okay? All right. So we're going to do this whole proof together. So we're going to take what we're given. Angle 1 is equal to 110 degrees. We're going to mark it in the diagram. We're going to write statements and reasons derived from the markings in the notes section. So it says angle 1 is 110 degrees. Angle 1 is, I'm going to get that 110 degrees on there in just a second. I've tried this 3 times. Angle 1 is 110 degrees. Thank you very much. And so we're going to come down here to a note section, and we're going to put angle 1 is equal to 110 degrees, reason given. Now, if we'd have gotten something else out of that besides that, we'd have written it, marked it, written it, and put it in the note section. Now, the next thing we're going to do is we're going to make what we're trying to prove the last statement in our notes. And we have to have a reason for that. So our job, our whole job, is to try to figure out what to put in that blue blank. And once we figure out what to put in that blue blank, we have to figure out how to make the rest of the proof prove that. Okay? So here we go. We're going to think of all the ways to prove that angle 8 would be 110 degrees. Well, we can visualize that angle 1 is an obtuse angle, and angle 8 is an obtuse angle. Now, there's some modern day textbooks, not that mine's not modern day, I'm just from the old school, you know, that calls those alternate exterior angles, and we would have nothing to prove. But we don't call those alternate exterior angles in this text, so we get to try to prove that those are going to be equal. And we could make up a name and say, hey, alternate exterior angles are equal to And we can make a rule out of that, which some have done. Okay? So somehow or another, we want to make our way from knowing that angle 1 is 110 to knowing that angle 8 is 110. And so we start planning a way to get there. Well, 1 goes to 4, we know that, and 4 goes to 5, we know that, and 5 goes to 8, we know that. So maybe I can work my way from 1 to 4 to 5 to 8. Now, what says if 1 equal 4 and 4 equal 5 and 5 equal 8 then? You know what that is, don't you? That's transitive property. Transitive property. But doesn't transitive property end with what it ends with? In other words, if A equal B and C equal D and D equal E, then A equal E. So if E is there, doesn't E need to be there? And if A is first, doesn't A need to be first? Well, yes. So that tells me that I'm going to slide this down here if I'm going to prove it by transitive. So if I'm going to prove it by transitive, then what I need to do is end up with the 110, and I need to start with the angle 8. So I've got to kind of think backwards. What was 8 connected to? 5, because they're vertical, see? So angle 8 is equal to angle 5. Vertical angles are equal. And then whatever's right here needs to follow right here. Angle 5 is equal to something. And I could see here that angle 5 was equal to angle 4 because they're alternate interior and the lines are parallel. So I need an angle 4 here. And the reason I can say angle 5 equal angle 4 is alternate interior angles are equal. And if I have the 4 here, then I need the 4 here. And so I need angle 4 equal to something on up the line. And what angle 4 was equal to on up the line was angle 1 because they're vertical. And if I've got angle 1 here, I need angle 1 here. And all of a sudden, hey, I've already got it. So I started with what my transitive conclusion began with, and I ended with what my transitive conclusion ended with. Therefore, transitive is justified. In the statements above it, notice that 8 equal 5, 5 equal 4, 4 equal 1, 1 equal 110, so 8 equal 110 transitive. See how transitive property works? Now, all of a sudden, we've got transitive property totally lined up. Let's make sure everything else is okay. Before we can say transitive, we need the first working its way to the last, and then we say first equal last, so transitive is justified. And we need every statement that helped us go from first to last and whether they're in the right order. So then we just make sure all our other reasons are justified. Given is justified. You can check that out. To say that vertical angles are equal, all you need to do is be able to see in the picture that they're vertical, and we can. To say alternate interior angles are equal, we need to know the lines are parallel, and it shows us in the picture that they are, so that's justified. Here's another vertical angles are equal, and we can see that in the picture again, so that's justified. And so every reason is justified somewhere. It all seems to be in the correct order, and so we're going to rewrite that over here real nicely. Notice that I didn't necessarily make my given statement first. I put it in a logical order to make it look like transitive property. So we're going to say statement 1, angle 8 is equal to angle 5. Reason, vertical angles are equal. Statement 2, angle 5 is equal to angle 4. Alternate interior angles are equal. Statement 3, angle 4 is equal to angle 1. Reason, vertical angles are equal. Statement 4, angle 1 is equal to 110 degrees. Reason given. Statement 5, angle 8 is equal to angle 10. I'm sorry, angle 8 is equal to 110 degrees. Reason, transitive property of equality. And so that's a nice little proof. And some of you sitting there looking and thinking, maybe going, I could have gotten there a little faster. We didn't have to go from 8 to 5 to 4 to 1. 8 is corresponding to 4, which is vertical to 1. We could have done that in one less step, you see. And so there may be more than one path to get there, and it could be that one path is a little shorter than the other path to get there. Somebody else might have said, well, I can do it a different way. I can go from 8 to 5 vertical, from 5 to 1 corresponding, and I can get there in 3 steps or 4 steps, see? So again, there's more than one way sometimes to get where you're going. That doesn't mean one person's proof is better than the other. It might be a little more efficient. But if you get where you're going, you got there. Just don't want to try to run out of gas trying to get there is the deal. All right. So that's Unit 3-2 daily work.